Okay? In addition to the structural in addition to the linkage isomers, the other main form of structural isomers we have are coordination sphere. And we kind of touched on this a little bit earlier. When we look at various complexes like Cr, Cl3, H2O6, we typically don't draw them out this way. We need to use the brackets and indicate what's going to be in the coordination sphere itself. So one complex we could get would be Cr, H2O6 inside the brackets, and then Cl3 on the outside of the brackets. If we prepared a synthetic route to make this particular complex, it's going to be violet. We can compare this to the complex that's Cr, H2O5, Cl inside the brackets, and then Cl2 dot H2O on the outside. This complex right here is green. One thing that I will point out so you make sure that you can recognize this, if we have water on the outside of the coordination sphere as a counter ion, we typically denote it with a little dot right here. Okay? So that's going to tell you how many waters are hydrated to this particular transition metal complex when it forms a salt. So if you see that little dot right there, that's what that means. One of the things to note here is that if you have a particular complex, in this case, the coordination number is going to equal 6 for the chromium in both instances. For that coordination number of 6, our complex over here on the left has 6 waters. More specifically, they're going to be bound to the oxygen in the water. A coordination number of 6 over here on the right is 5 waters directly bound to that transition metal center and 1 Cl- ligand. So in this particular case, we have 6 ligands, we have the same shape, but we don't have the same ligands bound to the transition metal center. So this makes coordination sphere isomers structural isomers, because even though the formula of the salt is exactly the same, the bonding to the transition metal center is a little bit different. And since the bonding is different, we have a violet complex versus a green complex. Okay? So when you see coordination sphere isomers, you need to draw out the entire salt. You need to put the complex ion in brackets. And some of the times, depending on how you synthesize these particular compounds, you can mix and match the ligands on the inside of the brackets and the outside of the brackets. Okay? So that gives you a depiction of what coordination sphere isomers are.